Alright, this is Mr. P Helps with Algebra 2, Unit 1, Topic 3, SLT15. This lesson we're going to be finding the exponential function when given 2 points on the graph. So if we know where it started and we know where it was after 6 hours later, then we should be able to figure out what this equation is as it's changing exponentially. And we don't have to have the y-intercept, so I'm also going to show you how to find the y-intercept when you're given 2 points that are not on the y-axis as well. So we're looking for, in this case, we're looking for where does it start and what number is it being multiplied each time. So after it's been 6 hours, it's been multiplied 6 times in order to get there. So we're trying to figure out, well, what is that rate? What is that number that it's magic number that's being multiplied by that many times? And what you're going to do is set it up as a proportion. So I'm going to take my 2,916, that's the total height of the answer, and set it up to equal, that's the starting point times the rate, so it's always a times b to the power of x. But we don't know what the starting point is, we don't know what the rate is, but we do know it's going to have to multiply by that rate 6 times in order to get to here. And we're then going to divide that by, well, the starting point here is the height of 4 is equal to the same starting point times the same rate, 0 times. Now I can simply divide. So 2,916 divided by 4 is going to give me 729. So it's top divided by bottom. So 729, a to the first divided by a to the first. Remember, when it's division, you subtract the exponents. 1 minus 1 makes nothing, so the a is gone. And b to the 6, 6 minus 0 is b to the 6. So now I just need to do the 6th root. So if you're doing that in the calculator, you have to press 6 first. And then you go to math, and that's number 5 of 729, and that's going to tell you that it's 3. So B is 3. B is 3. So now we know it's a times 3 to the power of x. So in order to find a, well, first of all, I know what a is. A is right there, so a is 4. But if I didn't know that, if I didn't have the y-intercept, I could simply take my answer for b, plug into one of the equations, doesn't matter which one, and solve for a. So if it was 4 equals, I'm going to use the one with smaller numbers, equals a, which we still don't know, times 3 to the power of 0. Well, anything to the power of 0 is 1. And so 3 to the 0th is 1, so that's 1a, so that means a is 4. So put it all together, you got an equation of y equals a, which is 4, times the rate, which is 3 to the power of x. And there's the equation. Now, I could do this question just the same, but I'm going to instead go to the actual lesson itself and find some questions. Okay, so let's say we're given this one. Okay, so this one's given the y-intercept. So we're giving 1 point here, and we're given another point over here. So I'm going to set it up just the same. So I'm going to always start with the one with the higher domain because I don't want to have to deal with negatives and my exponents. So I'm going to start with the one that has bigger domain. So in this case, which is 1, which is bigger than 0. So negative 6 is equal to, that's the height of the answer. So this one looks like it's going to be going down. So the height is negative 6 is equal to a times b to the first power. And this one's negative 3, which is equal to a times b to the 0th power, because 0 is right there. Now I can divide these. Negative 6 divided by negative 3 is 2. A divided by a is nothing. 1 minus 0 is 1. So b is 2. Now I can take that rate, plug it back into one of these two equations, and get my answer. Or I can just look right here and tell that negative 3 is the starting point. I know that because 0 anything is the y-intercept. So that means it's going to be y equals negative 3 times 2 to the power of x. Now, this is exponential growth, and this is one of those rare occasions where it's going to actually be going down even though it's growth, because anytime a is a negative, that reflects it over the asymptote. So it looks kind of like this. So it's being multiplied by 2, but it's going down because the number was a negative. All right, so I'm going to pick another one. So these were done just exactly the same. I can't do all of these questions. I want to get to one that maybe it's a little bit tougher. So we got one with a fraction here, and there's no y-intercept, so we can solve. All right, so I'm going to start with the one with the bigger domain. So 8 equals a times b to the 5th power divided by 1/2. So I'm going to change that to 0.5 equals a times b to the 1st power. Okay, so now 8 divided by 0.5 is 16. A's cancel because 1 minus 1 is 0. 5 minus 1 is 4, so that's b to the 4th power. Now, I would, okay, not sure why it's not writing. Pause. was it not writing? Okay. Alright, so there is our equation. Pen was not working there. I think it just paused on its own. Not quite sure when. So you can see all the work that we had just done. So we found the a, 8 divided by 32 was 0.25. Then we construct the equation, a times b to the power of x. Alright, let's go one more of these before we get to the homework. First one right here. So 28, I'm going to start with the one with the bigger domain, is equal to a times b to the second power. This is 4 equals a times b to the first power. So now I can divide. 28 divided by 4 is 7. A's cancel. 2 minus 1 is 1. Okay, easy question so far. So we now know the rate is 7. So it's times 7 times 7 times 7 times 7. We are not given the y-intercept, so we're going to have to solve for it. And we can just take our 7, plug into either equation, and solve. So I'm going to put it into the one that looks easier on the bottom. 4 equals a times 7 to the power of 1. 7 to the power of 1 is 7. Divide both sides by 7, so that means, let's see, 7a equals 4, divide by 7, means a is 4/7. Alright, so I can construct the equation. Y equals 4/7 times 7 to the power of x. Okay, getting to the homework. Alright, so when I look at this question at the begin with, I see 2/5 as the rate. Now, 2/5 is less than 1. And you would think that anything greater than 1 would be growth, and anything less than 1 is decay. But the exponent is a negative, which means anytime you have a negative, you have to flip it. So this means that 2/5 actually becomes 5/2. So when you put this in your calculator, you're going to notice that this is actually growth. This is not decay. We do have a positive starting point, so it is going to go up. Growth doesn't have to go up, but on top it would go up. If it's on bottom, it's going to go down. So in your y equals in your calculator, so you just do 2 parentheses. 2/5 is the same thing as 0.4, so I'm going to change that to a decimal in my calculator, to the power of negative x. And make sure you use a negative sign and not a subtraction sign, or you're going to get an error. Now when you go to table, 0, 2 is the y-intercept, 1, 5 is what it tells me is the next point. And the next one's 2, 12 point something, which isn't really going to fit. Now, if I go up, negative 1 was 0.8, and negative 2 was 0.32. Now, the best thing we can do is just kind of guess at that. Now, notice that this line, if you keep going, it's never going to get to 0. So it's kind of like, you know, if you take half of something, half, you'll never have nothing. So it's never going to reach 0 because it's 2/5. So it's 2/5 going backwards. It's 2/5 of what it was previously. If you go to the right, it's 5/2 because you remember the negative flips it over 5/2. Okay, so this line right here that I'm putting a dotted line is called an asymptote. And that asymptote is the line that the function will never reach. So this, if we go from left to right, and I know that's not the way you read a function, but if you go from right to left, you'll notice that this line will decrease forever, but it will never get below 0. That's why 0 is the asymptote. Now, another way you can find the asymptote when you look at the equation, it's always the plus or minus at the end. In this case, there was no plus or minus at the very end, so that's why the asymptote was 0. Had it been negative 1, this entire thing would have been translated down 1, and the asymptote would have been right here at y equals negative 1. So the asymptote is always this number right here, and it's the line that it never reaches. So the end behavior to the left of this function is going to be decreasing forever, and it's going to be approaching 0. It's not going to go down towards infinity because it's not going down. It is going down infinitely, but it's just never going to reach 0. All right, so the domain, left and right, this is all real numbers. It's going left infinitely, and this side's going right infinitely. It's going up infinitely, but not down. It is going down infinitely, so I want to make that clear. But it has an end behavior where it's approaching 0, and it's not actually going down below on the x-axis. So the range is everything that's above 0. So that's y is greater than 0. It never hits 0, so it's not or equal to. And then the y-intercept, which I did say before, is right there. It's at 0, 2. So 2 is the y-intercept. And that's a wrap. So please give it a like to help you find the equation when given 2 points. And watch for future videos and subscribe if you haven't done so already. Thanks again for watching. Have a great day.